I'm going to work through some problems. The first one that I'm going to start on is on your worksheet. If we use the worksheet, page 5, it's problem number 19. This one is going to be over how to set up a problem with units, showing how to convert 2.5 grams of hydrogen to grams of oxygen. So I call this a mass problem. So we're going to go from grams of hydrogen to grams of oxygen. And in order to go from one element or one compound to the other, we have to do a mass or a mass ratio problem. So the very first thing that you always need to do is either to make sure your equation is balanced or balance it, one or the other. So this one already has numbers, coefficients. Therefore, we know it's already balanced. You could double check it, but anytime I type up one, unless I mistype, that has coefficients, then it's already balanced for you. So you're not going to have to worry about that piece of it. So I'm just going to kind of start working through here and give you an example of how you would work through this. Okay, so the first thing that we're going to write down is what is given. There's 2.5 grams of hydrogen. So let's write that piece down. 2.5 grams of hydrogen. And we'll go ahead and do, since it's hydrogen gas, we'll go ahead and do hydrogen gas on there. Now, when you look at this formula, remember this tells us the mole ratio, not the gram ratio, the mole ratio. So if I'm doing hydrogen to oxygen, then it is 2 moles of hydrogen gas to 1 mole of oxygen gas. So there's my mole ratio that I'm going to be using. So that means that I need to change my grams to moles. So I'm going to need to do a unit conversion on there. So we have 1 mole of hydrogen gas. And then again, I need to do how many grams that would be. So do a quick multiplication of your table hydrogens. So we're going to take the 1.07794 and multiply it by 2. I'm going to get 2.01588 grams of hydrogen gas. So that's going to be my first step. Now I have the hydrogen to moles. I can do my mole conversion. So since it's moles of hydrogen gas in the numerator, the moles of hydrogen need to go in the denominator. Therefore, the moles of oxygen is going to go in the numerator. So again, it is 1 mole, be sure you get the numbers right, 1 mole of oxygen gas, 1 mole of oxygen, okay, to 2 moles of hydrogen. Now I'm to moles of oxygen, but they asked me for it in grams of oxygen. So now again, I'm going to do another gram to mole conversion or mole to gram conversion. So 1 mole. And again, you got to remember that if it is oxygen gas, O2, that we are going to have to double our oxygen. So that's the 15.9994 times 2. So I'm going to get 31.9988. Now again, according to which periodic table you're using, this decimal value may be slightly different on there. And that's that many grams of oxygen. Okay. So again, we have made sure everything is canceled. The only thing unit wise that is left is our grams of oxygen. The rest is now to do our calculation. Okay, and do double check my numbers. Don't assume that I am correct on there, but we're going to multiply our numerators, 79.997. We're going to multiply our denominators, 4.03176. Then we're going to divide those out and get 19.84 is what I got. So using significant digits, we only have 2. So that goes to 20. Now that is hard to tell if 20 is 2 or 1. So one of the things that you could do to clarify would be to put a decimal at the end of it. That would be one way to show 20. or you can always go to scientific notation 2.0 times 10 to the first on that. So be very careful to make sure if you have a number like 20 that you indicate in some way that the 0 is your second significant digit. Okay, and again, that is called a gram to gram conversion, or like I said, I refer to it as a mass to mass conversion. Okay, so the next one that I'm going to work through is page 146, the 4.3 conceptual question. It's actually a multiple choice question, but it gives us this balanced chemical equation, and it says for you to determine how many, so the question is how many moles of water, H2O, are produced when 22 grams, and it's 22 moles of octane combust. Okay, so that is my question. So they've given us the formula already, and my question I'm looking for is moles of water when 22 moles of octane combust. Now, I do know for some of you guys, you can kind of look and do a proportion on that and figure that out. I'm going to go ahead and do it as a stoichiometry problem on there. And so I'm going to do a mole ratio. And so when I go to look at it, I need to go from moles of octane to moles of water. Okay, so I come back up to my problem, and it's 2 for every 18. Okay, 2 for every 18. So 2 moles of octane produces 18 moles of water. Okay, again, I'm going to do my unit cancellation, and now it is just a multiplication. If you want to, you can go ahead and take 18 divided by 2. You got your 9, and then 9 times 22. And so that's going to give us 198 moles of water. So again, if I start off with 22 moles of octane, I know I'm going to produce 198 moles of water. Okay, this again is just a mole to mole problem. So we didn't have to worry about any of the mass. Okay, a little bit simpler than the last problem. Okay, so the next problem that I'm going to work through is page 148, 4.4. It's in the green. And I didn't write out the whole problem, but what it says is that you're given this formula for magnesium hydroxide, the active ingredient in milk of magnesia. You might have taken that. That's that white liquid stuff that you drink if your stomach's upset. Neutralizes stomach acid, primarily the hydrochloric acid, according to the reaction. So here's our reaction. So here's your magnesium hydroxide. Here's your hydrochloric acid. And so it neutralizes it, so it's going to form what's considered to be a salt and water. Okay, so this is our salt and water. Okay, now what the question actually asks is how many, or what is the mass of the hydrochloric acid? So what's the mass of the hydrochloric acid in grams that is needed to neutralize a dose of the milk of magnesia if it contains 3.26 grams of magnesium hydroxide? So basically, we're going to be doing a mass-to-mass problem in which we're going from 3.26 grams of magnesium hydroxide to grams of hydrochloric acid. So very similar to the first problem that we did. Okay, now the first thing that you are going to need to do when you're doing a mass-to-mass problem is to calculate the mass of both the magnesium hydroxide and the hydrochloric acid. So that is the first thing that I'm going to do. So for magnesium hydroxide, it is 53.3197 grams per mole. And then you can do acid is 36.458 grams. I don't know why I was thinking water per mole. Okay, so those are the values that I need, and I'm ready to get started. So I have everything that I need. So again, we're going to start with our given. 3.26 grams of magnesium hydroxide. I'm going to do a gram to mole conversion. So we said it was 53.3197 grams for 1 mole. Okay. Cancellations. So now I'm to my moles. I need to now go to hydrochloric acid. So I go back in and look at my prefixes. So it's a 2 to 1. So 2 moles of hydrochloric acid for every 1 mole of magnesium hydroxide. Okay. And the final step then would be to take my moles of magnesium hydroxide and change it to grams. So 1 mole, of hydrochloric acid, not magnesium hydroxide, said the wrong thing again. So I'm going from moles of hydrochloric acid to grams. And again, my mass there was the 36.458 grams of HCl. Okay, and so that is, the rest is just calculations to run the numbers and see what we get. Okay, and as I have always said, double check my values, but when I multiplied my numerators, I got 237.70616. And I know some teachers will tell you to do your significant digits at this point, which you would just really have 238. I do go ahead and hang on to mine, 53 times 1 times 1, and then do your division and do my significant digits at that, which I have 3. And so I get 4.46 grams of hydrochloric is needed to neutralize 3.26 grams of magnesium hydroxide. Okay. So again, check my calculations, make sure I did correctly. And again, just make sure everything cancels. So you've got your grams of magnesium hydroxide, your moles of magnesium hydroxide, your moles of hydrochloric, and then to your mass of hydrochloric.